Today, I'm going to talk a bit about platform engineering. We've already had some great sessions on internal developer platforms with GitHub deployment environments, so definitely check out those recordings if you haven't been with us this morning. So as Ahmed just said, I'm a Microsoft Azure MVP Learn expert in Hamilton, so feel free to reach out if you've got any questions. So I'm going to take a bit of a different stance with this. Unfortunately, it is going to be a bit higher level with PowerPoint, but we've discussed a lot about developer environments and platform engineering. But what I want to showcase today is essentially why it makes that much of a difference and why you would look at platform engineering as a capability, for example. So we'll get into it. It's a lot of content to cover. So let's just get started. So what is platform engineering? So platform engineering is more than just automation or a DevOps rebrand. It's really about creating a golden path that empowers your teams to move faster without sacrificing security, reliability, and governance. And it may sound very similar to DevOps, and we'll get into that shortly. But think of it as more about building your internal, like an internal developer platform, whether it's deployment environments or a custom GitHub app that your teams want to use. It's about crafting reusable tools and patterns that abstract away from the complexity so your dev teams can focus on what really matters, which is delivering the customer value. So it's increasing the resiliency of your systems, the efficiency, and really about the value that your business is going to deliver to your customers. So there's a couple of key pillars when we're thinking about platform engineering. One is creating and managing cohesive platforms. So the first pillar really speaks to the foundation of platform engineering, which is really about bringing the cohesive platforms together. So think of the platforms as a backbone of your digital ecosystem. So well-designed platforms, not just a collection of tools and services. It's about a harmonized system that integrates your infrastructure workflows and policies. So what makes this important is that it's aiming, like platform engineering is aiming to help eliminate your silos, increasing collaboration, and providing standardized frameworks and shared services that your teams can use. So we'll just contrast that with more of an application engineering and lens as well. So you've got your platform engineering, but now we'll sort of contrast with application engineering lens as well. So unlike your application engineering teams, which focus on individual solutions, the platform team or the platform capability is operating at a higher level, which is addressing needs of multiple teams and their use cases simultaneously. So it's about creating a system that supports the entire organization, not just one app or service. Sorry, it's clicked, not just one app or service. So it's really about supporting the whole ecosystem in general. So, and the second pillar that I want to touch on is enhancing the developer productivity, which is perhaps the most visual benefit. So like developers are lifeblood of your organization. And when I use the term developer, I'm meaning anyone that's really making systems or applications or workloads that you're consuming, whether customers are consuming it from a business perspective, like if you're a banking, you may have a mobile app, for example. The developers are the people working on that. If you're got operational teams that are doing things like user account onboarding, I would also class those as developers as well. So it's a very generalized term. It doesn't mean that your developers are people that live and breathe Python or anything like that. It's really about trying to avoid the silos together and stop fragmented workflows and manual processes. And operational efficiency is obviously the third one as well. So it's more about things like your security, making sure that you're not reinventing the wheel each time. So at its core, platform engineering enables platforms to act as a backbone into your digital systems. What does this actually mean? So enterprises rely on a multitude of systems, tools, and workflows to develop value. Without a unified backbone, these systems operate in silos, leading to inefficiencies and misalignment across your teams. So the platform capability provides a structure and integration needed to bring these elements together. They serve as the foundation for seamless communication, cross-functional collaboration, and shared innovation. As I touched on previously, it's about centralizing the resources and capability as well. So this is where your platform engineering team truly shines as an enabler of efficiency and standardization within your organization. So rather than having the teams reinvent the wheel every time they need infrastructure tools, services, or platforms, it's providing a centralized capability that can be accessed and reused across the organization. So examples of this: self-service portals, like as we've talked about in other sessions with deployment environments or custom integration with GitHub, but the things like shared CI/CD platforms, centralized monitoring and logging tools for operational visibility, predefined templates for your infrastructure provisioning. So making sure that you have a mechanism, or your platform engineering teams, is really about centralizing and duplicating the effort, which aims to accelerate time to market and help with consistency. I just want to recap again. So some of the value that you'll get from looking at platform engineering as a capability within the organization that you're looking at is reducing operational costs, accelerating feature delivery, ensuring on-demand scalability, minimizing manual effort, and enhancing competitive advantage. The aim for this is that you're reducing those silos down. You've got a team or a capability that will work on centralizing and bringing this capability in so your developers can go faster, not having to reinvent the wheel every time, and everything's going to be secure. So it's really about accelerating feature delivery by providing your developers with capability, standardized tools, and automated pipelines. So the cloud, for example, has become quite an easy sell in the early days, where you're offloading a lot of the capability from on-premises environments where you had to manage the racks, you had to manage the hardware components, you had to manage the capacity and the storage. And then shifting to the cloud allowed you to focus more on the tools and the capabilities. So the platform engineering really is the next evolution of that, of going, okay, well, based on the services and capabilities that the cloud offers, as an example, it's become a lot more chaotic than it has originally, and a lot more complex. So in order for a developer to get up to speed quite quickly in an organization, especially if they've never touched the tool sets before, and the compliance and industry requirements required for that organization, it can lead to some inconsistencies, especially if their targets of actually needing to get stuff up and running and delivered within a certain time frame doesn't quite match the business strategy as well. So that's where platform engineering teams, in my view, is kind of the next iteration of that. So you do need to align your platform strategy with your business strategy. Ideally, it's not the other way around, where someone's going, well, we've got a platform, we want to develop a platform engineering team, we've got this technology to make this happen, now let's try and shove it into our business strategy. It really should be a business strategy level delivered capability. So a well-aligned platform strategy really ensures that the technical incentives and actively contribute to the organization's vision and mission. So that's one of the first things I'd recommend when you're looking at standing up a platform engineering capability within your organization is what is the business strategy in the next 3 to 5 years? You may not know it. You may only have a view of the 6 months, for example, but what are the problems that you've been having? Is the work that your team is doing or the development capability doing, are they really supporting what the business goals are? Or are they solving the right problems, or are they simply creating more complexity? Because misalignment between the platform and business objectives often leads to wasted spending on infrastructure that doesn't drive business value. And we see that all the time with organizations where a management or a C-suite might go, we want to do this, or they've already signed a deal with another partner to deliver something, but there's no method of, okay, we've got a standardization framework, or we've got areas where one development may be doing something different and another one may be doing something another way. So platform engineering helps to sort of bring those in and standardize it at more of an operational layer than something you'd be doing with like architecture review boards and things like that. So let's discuss a bit about platform engineering versus DevOps. So they're not the same and they can coexist. So DevOps is more of a cultural movement that advocates improvements around developer automation, autonomy, and collaboration. Like successful DevOps strategies typically involve multiple tools, best practices to remove roadblocks from the development process. Where platform engineering is actually a tangible strategy for realizing those outcomes. So DevOps is more of a collaboration, it's more of a culture, it's the operation development teams working together. Platform engineering supplements that by giving it more of a strategy that you can help realize those goals by actually developing the tools needed to help support the DevOps teams or the developers in obtaining the productivity that they need. So the platform engineers are responsible for creating and managing reusable, scalable platforms while overseeing the infrastructure tooling and developer experience, where DevOps engineers kind of bridge the gap between the developers, operations team, managing your CI/CD pipelines, monitoring, and automation from more of an application view, but they can coexist. Remember, DevOps is more of a culture than a job role. Where the sort of the difference as well between DevOps and platform engineering come into play is the internal developer portals that we've talked about in other sessions as well. So they enable mechanisms for self-service on-demand access of infrastructure components by either a CLI interface or a web interface. And that's really what the platform team is building, is more of that standardization. So about to allow those teams and that culture to really thrive. Whether you're building systems for internal teams or external users, platform design is really the heart of driving your productivity, innovation, scalability within your organization. So the first principle of platform design, so this is now when you're starting to go, okay, we want platform capability. What does this look like? What does the design look like? It's really about to empower your users and your developers, whether they are developers, business teams, or end customers. I think there's no surprise that a well-designed platform streamlines the workflows and allows teams and users to do what they want best. I think it's always best to keep the customer at the point of mind or customer obsession, because they're the ones using your platform at the end of the day. And this goes back to what I talked about earlier around making sure that your platform capability aligns with your business strategy as well. I think there's a mind shift here about thinking of your platform as a tool that amplifies productivity by providing interface, seamless integration, and automation to help avoid and eliminate repetitive tasks as well. Again, the teams are going off and delivering capability and features and functionality, but the platform team is really about taking all that information and designing and avoiding those tasks that are repetitive all the time. But platforms must be built with adaptivity in mind as well. So like technology is constantly evolving. We've got Microsoft Build coming up in the next week or two. Who knows what kind of new insights and capabilities and features that will be bringing to us. If we had a platform roadmap that only existed 1 year ahead of time, I think we'd all know that we may not have a platform, or we may not have the capability that will be met by that stage. So we want to make sure that when you're designing platform capability, that you keep adaptivity in mind as well, because the business needs to adapt to new challenges. The whole generative AI, transformer models, huge shift in the market. If you had a roadmap with your platform that indicated, no, we weren't going to use some of those capabilities for the next 3 years, or you didn't even know that they were coming out, you would already be behind in the market as well. So you need some flexibility in designing your platform capability. Just recapping back on the business and technical alignment. So platform engineering, just if done correctly, does support innovation, and it should aim to reduce your friction and collaboration between the teams as well. So keep this in mind of what success looks like and what you should be aiming to get when you build out this capability as well. And it is an infinite loop. So providing developers with the right tools and environments to build successfully and efficiently. Infrastructure as code is a huge part of it as well. Yes, you can have self-service portals that will go and create all this thing for you, but there's a whole lot of capabilities in the back end as well around like infrastructure as code capability that would sit within the platform engineering team as well. CI/CD pipelines as well. So we've discussed at a high level what is platform engineering and like how does it solve some of the problems that you may have in terms of the silos, just that everyone doing something a bit differently, no one really concentrating on improvement of the platform in general, but how do you actually build out this capability? So to do this, we can follow the platform engineering capability model. So there's a couple of different models out there. So the CNCF have a model, and this is kind of what the Microsoft one is based on. But there is a capability model, and you can go to the link on the screen or the QR code as well to go directly to the Microsoft Learn page. But the model emphasizes incremental progress over revolutionary change. So I think this was talked about in a lot of the earlier sessions as well. Having an MVP is fine. You start small and you scale as you learn. So your organizations can start reducing their risks, avoiding technical debt, and ensuring the platforms involved with both the user and the business need. So minimum viable product is a great way to begin, allowing your teams to focus on core functionality while leaving room for future enhancement. Again, platforms are not static. They evolve through a life cycle of development, adaptation, and optimization. So the capability model ensures that these life cycle changes prioritize reliability, scalability, and governance. For instance, moving from the initial phase where your efforts might be fragmented, and I would assume a lot of organizations would be in this space, through to managed and optimized. It involves implementing consistent governance practices, provisioning systems, and feedback mechanisms, which is a huge part of it as well. Again, the infinite loop. Feedback will determine where you go next or what you need to improve on. So each level in the capability model represents progression. So basic adoption of platform tools to refined governance and proactive measurement as well. So the capability model is not just a framework for understanding where you are, it's a tool for planning where you need to go. It provides a structured way to assess your current capabilities, identify your gaps, and prioritize your efforts. So we've discussed at a high level around the platform engineering. The capability model really gives you how you go and do that and where you sit currently and where you want to go to. So we've got the initial stage where things are reactive, ad hoc, driven by a few passionate engineers trying to keep the lights on. There's a hero culture, minimal investment, and focus on the urgent tasks, but not necessarily the strategic tasks. So then we move right, we hit the repeatable stage. This is where your processes start to emerge. There's growing awareness of governance and toolings, but it's a bit inconsistent still. You might still have pockets of excellence, but still no golden path. You don't have any budget buy-in, and standardization is still maturing. Again, platform engineering is not just a switch you flip, it's the capability you build. And so you do move over those steps. So I think that's, yes, sorry. So platform engineering, as we've discussed, is about creating unified developer-centric experience. So to achieve this, we need to divide the platform into distinct areas that can work seamlessly. So one is engineering systems. So at the base of the strategy, we have engineering systems. That's the tools and the workflows that your developers use to interact with daily. So they're things like the IDE editor, DevOps, for example. They provide your developers with a robust environment to create, debug, and test code efficiently. Then you've got your source code control. So that's about enabling your collaborative developer experience with versioning and synchronization. You have to remember, yes, it's all good to go out and build these fancy tools that allow self-service, but you need to think about work item tracking as well. So how do you streamline from a platform engineering stage that's enabling this capability to your internal developers or users? You need to track the work as well and what they're trying to do and make sure that the platform aligns to every step that they're trying to deliver that capability as well. Moving up, we've got the application platform, which provides the infrastructure and services that really underpin that. So they're things like your runtime infrastructure, so your compute networking and storage. This is where things like Kubernetes and PaaS capabilities sit as well. You've got your security and compliance, which is like RBAC, so role-based access control, auditing compliance frameworks. Continuous improvement really underpins all of this. And that's things like your observability, your monitoring, and making sure that you're collecting the right data as well. And then your operations team. And then on top of that, that's when you start working on your application templates. So these are things like your languages, your source codes, your API resources and pipelines. Just wary of time, so I'll just skip ahead a bit. One of the things touched on around deployment environments, for example, is really in platform engineering that comes up a lot, is really about deploying environments as a service. And I think this is where, from us in the technical world, really love to play in, because that's really about, I want Kubernetes cluster running AKS. I want it to be secure with my industry standards and my organization standard as well. So I'll deploy that. And that's really about deploying an environment as a service. So the traditional approach is really about manual processes. You're giving your developers access to more than they need to. You don't have a lack of standardization. And that leads to things like security risks, unstandard practices, and things like that. So this is really where your platform engineers can help curate those templates in the Dev Center catalog and define the environment mappings. Your developers can then interact with these environments through things like tools, portals, CLIs. They can build and debug and run their automated pipelines as well. So it's really about going from modular, I want a storage account, for example, here's a storage account module, to let's deploy an entire environments as a service. And this is when people think platform engineering, this is kind of what they would go to straight away. So just create a platform that's resilient for today and ready for tomorrow as well. Yeah, identity and access management. So, for example, that's a huge part of platform engineering. So it's really about aligning your identity and your governance as well, and your configuration management. So when you start to think of environments, deploying environments, this is where things like GitOps comes into example as well, with being able to deploy through Azure, like through these manifests, Helm charts, and other configuration files. And then, of course, developer self-service. So self-service is not just convenience, it's a key enabler for speed, innovation, and scalability by really giving your developers the ability to provision your environments and deploy applications autonomously by removing the bottlenecks, reducing administration overhead, and unlocking productivity. There is a balance between self-service and governance. One of the things to keep in mind as well is how you structure your team and your layouts of security. And I've touched on it a lot, but feedback loops view. Every organization's platform engineering capability will be different depending on the culture of the organization, the type of systems you're delivering. But you need to make sure that within the platform engineering capability, you have the feedback loops coming in as well from your developers, so you know what you need to work on in the short term and the long term, and making sure that the systems and the environments that you're setting up are fit for purpose. So again, self-service, I think it's a no-brainer, and it could be a portal interface, or it could be APIs that your developers call that already have a lot of the logic built in. It really depends upon the maturity stage. And again, something like Jerome mentioned in the previous session, deployment environments, for example, is really the UX that the developers would interface with, and then the developer APIs sit underneath that. Yep. This is an example of a cloud native operational excellence project as well. One thing that differentiates a bit differently is that you've got your developer portals like Crossplane and Backstage, but something like Radius, for example, which is more of an application model centric that comes from the Azure incubation team, actually sits down in the application model down below as well. So there is a gap, I think, recognized within the CNOE project as well. But yeah, keep in mind things like integration of CI/CD, ChatOps, GitOps, deployment environments, Radius, DevBox, and yeah, that's me. But hopefully that's made a lot of sense. And
that's really good. Yeah, thank you so much, Luke. I know that platform is like a really hot topic. A lot of people really looking, like trying to achieve that state where like you could, or a developer could just jump in and say like, hey, I want this environment. You don't have to scramble through to understand what is it that they need. And I think that you've explained it really well to actually understand what needs to happen. How would an organization adopt that? It's more, like you said, it's not more than just a tool or like a set of services. It's more of a way of thinking and methodology. Yeah, so that's really cool. Thank you.